Welcome back to Energy Technology. I'm Jackie Park, Editor-in-Chief of Global Data's Energy Titles, and your host for today's episode. Today we're tackling heat decarbonization, one of the most significant yet under-discussed challenges in the energy transition. Heat accounts for nearly half of global final energy consumption and 37% of energy-related emissions, but the way forward remains unclear. Electrification is often touted as a solution for heat, and progress has been ongoing, yet limited. So, is electrification really the answer to decarbonizing heat? Joining us today to discuss is Blaine Collison, Executive Director at the Renewable Thermal Collaborative and former Director of the Green Power Partnership at the U.S. Environmental Protection Agency, Dr. Chris Bataille, Adjunct Research Fellow at Columbia University Center on Global Energy Policy, Cecilia Springer, Principal Associate at Synapse Energy Economics, and Neil Harrison, Co-founder and Director at low-carbon heat consultancy Reheat. Welcome, everyone. Let's start with the big picture. Cecilia, many point to electrification as the backbone of heat decarbonization. What convinces you that this is the case?
The answer is very clear when you think about it conceptually, or just the physics of generating heat. What are other ways that you can produce heat? I mean, there's radiant energy, like directly harvesting from the sun, like in greenhouses, but obviously that's not going to scale for manufacturing. And then there's mechanical energy, like friction, but also not going to scale. So it's really about electrical energy.
Chris, you've done a lot of work on economy-wide modeling for Paris-aligned policy pathways. Overall, has your work consistently favored electrification over non-electric low-carbon heating methods?
So there are literally thousands of models doing this out there. There was a big wave of including carbon capture and storage in these models, even though it hasn't really been developed. They now tend to have a lot of hydrogen, green hydrogen, but there's a lot of issues with that. Like it's very, very, very expensive. Using heat pumps, using heat batteries, the economics of that tend to pencil out better than both CCS and green hydrogen. But most models in place right now don't include those options. So you're not going to see a lot of it in the literature, but it is growing.
Blaine, let me come to you. Is there any counter evidence that makes you question the assumption of electrification as a silver bullet?
Electrification is a huge piece of the solution set, without question. Decarbonizing heat with renewables is very similar to the decarbonizing electricity with renewables conversation. Where it gets different, with electricity, an electron is an electron, and any electron will do the work of any other electron anywhere, and you can interchange them. The electron is sort of the end product. Thermal's about heat. And gas, fossil gas, has been the fuel to actually make heat. Industrial processes, manufacturing, buildings even, heat requirements exist at different ranges, different technologies, different costs, more complicated processes. So even if you just dropped in electrification of the process, well, now you have to change the process. You got to do a little more matching of solutions with requirements by sector, by application. We don't think there is a way to simply electrify the global industrial economy.
Would you agree, Neil?
Reality is heat pumps and electrification can't do everything. There's no silver bullet, only silver buckshot.
So the consensus seems to be that electrification will form the foundation, but it may not be able to deliver alone. I'd like to now dive more into the options, opening up the discussion to everyone. Which electric heating technologies look most promising right now?
I do think heat pumps are one of the most promising electrification technologies at the moment, and they are applicable across the residential sector and the industrial sector. The reason that they're popular for both is that they can lead to massive efficiency gains over, for example, like a natural gas boiler, and they can provide 200 to 300% efficiency gains, which means that for every unit of electricity going in, they're producing 2 to 3 units of heat. So that can really tip the scales in favor of the economics of electrification. Electricity is more expensive than fossil fuels pretty much everywhere around the world. So the only way that you could potentially reduce your energy costs when electrifying is if you're also getting those efficiency gains. I think electric boilers tend to get a bit overlooked in the discussion of electrification, but that's for a good reason. They really don't offer much efficiency improvements compared to fossil fuel boilers. The advantage of electric boilers is that their capital costs are pretty low and they're very, very established technologies. And there are certainly examples of electric boilers being deployed, presumably in areas where there's very, very cheap electricity. But again, I think it just comes down to the challenge of the electricity versus fuel price ratio, sometimes called the spark gap.
Heat pumps are certainly a place where everybody starts. There are some really interesting electric boilers that are worth attention. There's thermal storage, heat batteries. I mean, as an electrification technology, right? Because they are using electricity to produce and store industrial heat. Thinking about the intermittency of renewables on the electricity side, thinking about production facilities that run 2-3 shifts, the opportunity there is massive. Heat batteries typically use storage media that are pretty straightforward. Thermal storage companies are using sand beds or crushed volcanic rock or refractory brick, pretty low cost and pretty scalable.
So heat pumps are leading the game and electric boilers and heat batteries also emerging. Do you see deployment trends of these technologies varying or being broadly uniform across both applications and markets?
North America is a little unusual because we have such low gas prices relative to electricity of anywhere in the world, except maybe the Middle East, maybe parts of Russia. So it's a little bit of a struggle, but in the vast majority of the world, it's really a no-brainer to put a heat pump into heat buildings. But it's a relatively small amount of heat compared to industrial applications.
So industrial heat pumps can meet heating demands for up to maybe 200 degrees Celsius or a little bit higher. And that's what we would typically think of as maybe low medium for producing things like food and beverages, textiles, and pulp and paper. And they use steam or hot water to make things. In some places, like the US, that kind of manufacturing is the majority. But there are other countries with different industrial structures and a lot more demand for high temperature heat. So producing things like steel and cement and the really heavy industries. Heat pumps are never going to be able to produce steel. So there are even earlier stage technologies for some of these industries, like molten oxide electrolysis for cement production and other forms of electrowinning, but those are probably decades out for going to scale. That being said, I think steel is an interesting case because steel can be produced from melting scrap steel in electric arc furnaces. So not only are you reducing material use and emissions by recycling the steel, you can also use clean electricity to power that. And that's a very established technology.
What are the greatest hurdles to electrifying heat right now?
100% is cost. It's the cost of the equipment and it's the running costs of that equipment.
What market or regulatory innovations could help address these challenges?
Heat pumps are very exciting, but not only do you have to buy the equipment, and that's quite expensive at the moment, but then you have to potentially significantly revamp your facility and install new electrical equipment to be able to support that electrification. And that can be very, very expensive. It's something that seems very solvable to me in terms of being able to change how you deliver and integrate the heat pump, and then also at the planning level, looking at grid expansion and so on, and aligning that with planning for industrial electrification.
When General Motors or Microsoft signs a 15-year PPA for a wind farm that will be built, GM or Microsoft or Google's commitment to that project de-risks the project. And we can sort of see the results in the curves on wind and solar deployments. Certainly opportunities for collaboration, right? The demand side and the supply side have an opportunity to meet each other right there at the market.
Really what you need are some of the more unpleasant policy levers like carbon taxes, like bans on fossil fuel equipment. Let's reform the electricity market and pricing models. That would be very, very helpful. But also, to get people to shift, there has to be a kind of a thank you, a reward for moving to a low carbon source of heat. So there needs to be some form of subsidy, whether that's a grant aid or something like the Renewable Heat Incentive, which ran for 10 years and delivered a step change in renewable heat.
Where in the world have we seen some of the right framework so far?
I have to say, the Europeans in general are running a broad-based emissions cap and trade system, which puts a background carbon price on emissions. So that's one side of it. But they also have quite high gas prices too, because they've been cut off from cheap Russian gas coming in. And so they've got what gas they have plus LNG they import, which is quite expensive. So they're squeezed between the carbon price and high gas prices and the implementation of a lot of solar and wind in the European Union. You're seeing a lot of heat pump uptake, both on the building side and on the industrial side. Germany is indicative. They have a large industry. They're trying to decarbonize it because they're losing a lot of market share to China. They've got some innovative programs. They have a contracts for different support program for technologies that can produce first 60% and then 90% plus. The companies would bid for that money because a lot of this is just upfront capital to experiment with the new equipment and then the long-term cost of electricity to drive it. You need support on both those things. In the US, California's got a background carbon price, New York does. Texas is interesting, right? Because they're allowing as much wind and solar as can bid onto the market. And that provides the electricity that's needed. And there's much of the day, Texas has quite low electricity prices. With heat pumps, the big thing is the upfront capex, but then the electricity to run it. And it's about 2/3, 1/3. It's the other way around for heat batteries, probably about 20% capex and 80% the cost of the electricity used to fill those batteries. A lot of this is going to hinge on electricity market reform, investment tax credits, production tax credits per BTU or gigajoule. Those are things that have been used in the States quite successfully. You need the carrot and the stick. The stick is the carbon pricing, and the carrot is the subsidy for early applications.
One of the things we saw in the Biden administration, within IRA, there was a set of awards within the Department of Energy's Office of Clean Energy Demonstrations for decarbonizing industrial heat. The feds were making available $6 billion in incentives, but it had to be at least a 50-50 cost share. What they were looking for was scalable portfolio approaches, not sort of one-off things. The objective was to help deal with the cost of learning for projects, 1 through 25, so that projects 26 through 126 could just proceed on their own. That's the kind of policy that is particularly useful. It's not a matter of policymakers saying, here's a gargantuan check to cover everything. Companies are willing to make some investments here, but they could use a little help.
India is a really interesting place right now to look at electrification because they've been so successful in decreasing the price of renewable electricity and creating mechanisms for companies to be able to procure it. If you're looking at heat pumps with their efficiency gains, that makes electrification possibly very, very viable there in a way that it's not almost anywhere else in the world. But India needs to be able to deliver cheap renewable electricity at scale. And so that will have challenges, but I do think it's a very promising area. I really think that identifying where electrification is most promising kind of comes down to the electricity and where you can deliver reliable and cheap and clean electricity. And places like India and China are leading in that, but places like the US have a regulatory structure that arguably has a lot more potential to facilitate industrial electrification. And I'm talking about things like deregulated electricity pricing, where industrial facilities can have different rate structures or participate in efficiency programs or demand response programs to kind of get paid for values that they're providing to the grid. So I think it's a combination of cheap electricity itself and then a good regulatory structure.
Looking ahead, what is the outlook for electrifying heat?
Early case studies and examples have mostly been demonstrated in the US, Europe, and more developed or industrialized countries. I do think that significant scale up will be coming probably on the time horizon of the next 5 to 10 years. But I think when you hear about potential massive scale up of these technologies, you have to take it with a bit of a grain of salt because it takes time to install them and also takes time to scale up manufacturing. And so again, a lot of the manufacturing of the heat pump technology itself is in places like the US, Japan, and Europe. And that technological diffusion and manufacturing scale up process will also take several years. You could foresee a scenario in which a country like China, good at achieving economies of scale and making technologies cheaper, rapidly scales up industrial heat pump manufacturing and brings down the cost of the equipment for everyone in the world, the way that they did with solar panels, electric vehicle batteries, etc. That would be transformational from a technology perspective, but would obviously have a lot of geopolitical implications. I think there could also be a future where electrification technologies become feasible in places where the grid is not necessarily set up to handle electrification at scale. because of the growing affordability of distributed energy resources and renewable resources that can support that electrification instead. So countries like Bangladesh that have a lot of manufacturing, but a very unstable grid situation, with adequate support and investment, there could be a way to electrify with microgrids and on-site renewable energy to some extent. Of course, it's difficult to build enough, for example, solar panels at an individual industrial site to meet electrified heating demand. So this would likely also require lots of technologies like thermal batteries or even clustering industries together. But I think there are some interesting possibilities there that electrification opens up.
We are going to deploy an amazing amount of renewable thermal technologies, including massive stack of electrification. We're also going to need some other stuff because the scale of the problem is so big. And frankly, the clock is running. 1.4C is in the rear view mirror. So let's go.
That's it for today's episode of Energy Technology. Find more news and insights into all things energy on power technology, offshore technology, and mining technology, all free to access. For quick daily updates, make sure to subscribe to our newsletters. I'm Jackie Park, and we'll see you next week.